I have prepared a few slides. It says a summary and a look into the future. I think it won't be really a summary because it's not possible to summarize 3.5 days of discussions. So let me just make a few remarks on concerning this conference. I mean, some statistics, the very fact that we managed to get about 200 people discussing thorium here shows that there is a worldwide interest in thorium. And one of the things that we're trying to do is attract the attention of politicians. And we were fortunate that there were a number of prominent personalities that were kind enough to come and attend our conference. Here we had a full program. We listened to 47 presentations from speakers from 19 countries, and we covered a lot of subjects, as you just realized here. I mean, there is a clear sign of increasing interest in thorium worldwide, reaching even nuclear industry. We heard announcement from Areva that they have now put the word thorium on their program. That was the positive aspect of it, but it will. They immediately said it will take them 100 years to get there, so I don't think that will change the world on the short term. I will not repeat why we like thorium. I mean, this has been done a long time, and as I said, in Europe, I mean, the push for using thorium came from the ADS idea that Carlo Rubbia has been pushing for a long time, but this type of plot has been shown by almost every speaker in this conference, so I think we don't need to go further on that. I also borrowed a plot from Carlo Rubbia to remind you of what are the challenges about thorium. It looks that U-233 is very good because on most of the energy spectrum is actually doing better than U-235 or plutonium. However, when you try to use it in a pressurized water reactor, the way we do pressurized water reactors these days, it doesn't work because of neutron inventory. You have a strong capture on thorium, and then because of the long lifetime of protactinium, it takes too long to bring you a little bit back for the investment of the neutrons into capture to get the fissionable material. So this is one of the problems. And if you want to go to the higher end of the spectrum where you would like to go if you want to do transmutation, then it's even worse. You can see that actually in that region, U-233 does not do as well as plutonium, for instance. So you have to do something. And what are the options? One is you can make a thorium blanket to breed uranium-233 around some system that you have running on uranium. Or you can move the fuel around continuously so that, so to speak, you always have fresh fuel in your system. Either you do this with a pebble bed type of a reactor with once through a type of cycle, or you do a molten salt type of detector where your fuel is liquid and you continuously recirculate the fuel. And we heard a lot about molten salt reactors. And the other option is that you can have an accelerator-driven system, and this is the solution proposed here at CERN by Carlo Rubbia and promoted by iThEC. And we also heard a lot about this. And the idea in this case is that the accelerator is bringing the extra neutrons that allow to sustain the system. Thorium blanket challenge, it's interesting because it's a reality in India. The Indian strategy is based on three steps, three systems, three technologies. You've heard that a lot, and we're not going to discuss that here, but it's indeed the most advanced scheme for the use of thorium. It includes everything from front end to back end of the fuel cycle. And in preparing all this, India is also improving the knowledge we have on thorium properties, However, there remain some issues on the complexity of the present scheme, 3 different technologies to maintain at the same time. Sustainability, if you start running out of uranium, then the thing stops, and the issue of nuclear waste is maybe to also be addressed in this. Pebble bed were not actually discussed this time, so we can actually go to the next thing. This is by far the subject that was most, well, no, that's not true. It was about as much discussed as ADS. There were about 10 talks, and we already had the discussion on this. This is clearly a line of research that would benefit from synergy between the various institute and countries interested, because we hear that a lot of people doing similar things in various corners of the work, and I think this could benefit from cooperation. In fact, I was trying to just find 2 slides to show the general schemes, and I wanted to show 2 of them, and I found the talk, for example, of Paul Madden from Oxford, and then I chose another talk to get a totally different scheme, and I found this exactly similar slide from Mrs. Merle-Lucott, which seems that in practice cooperation has already started because people share transparencies. Molten salt critical reactors, I think one issue would, one R&D that could be interesting is to ask whether this type of system can work with a neutron flux which is fast enough to really minimize waste production. This is the issue of licensing is certainly not to be minimized and should probably be addressed very early by these people, because somebody mentioned the problem of containment. You have to take out of the core part of the fuel, and you have delayed neutron emission, you have chemistry online with the corrosion aspect and so forth. So this is, for the least, very challenging and something that has to be considered very early. Over the past 20 years, safety rules have evolved a lot, and there are a number of things that were easy to do 20 years ago that become harder to do these days. So licensing is certainly one of the issues. What is interesting is that industry seems to get interested in MSR. The next major subject was accelerator-driven system. There was actually a lot of talks, 16 talks. But this is a field which is not at the same level as MSR. There is a lot of advanced studies. Physics is perfectly well understood, and you heard there are actually concrete things that have happened. We have a 1 megawatt beam at PSI. There's been a target that worked at 1 megawatt, and many of the elements actually exist and could be rearranged to make a prototype. We had lively discussion on accelerators, but the interesting thing is, everybody says my accelerator is better than yours, but there is no doubt that both of them could achieve what is needed for these type of systems. Spallation target, core design. We got presentation on systems and on MIRA. There's a TROISC and the Chinese ADS, which are systems geared towards burning minor actinide, and there was also a discussion in ADS in India. And we also heard about concrete plants, I already mentioned that, and some reactivity measurements, corrosion, and so forth. Actually, there are several types of ADS that are being proposed. In addition to the energy amplifier, Carlo Rubbia proposed this quite advanced design that was worked out with Acre solution, which is a system with a K effective of 0.99 and above. He one thing that I would like to point out, and that has perhaps not been appreciated to its value, is that Professor Rubia made a simulation that shows that the compensation mechanism to stabilize the K of the system actually works. And I think there is no doubt that this simulation works because it has been validated in experiments here at CERN. And the benefit of this is that he showed that you can extend the burn up to 150 gigawatt day per ton, and I think this is certainly a very impressive thing. So if we can realize a system like this, we already know that this can happen. And we also saw some discussions of other types of ADS where the beam uses the liquid fuel as a target directly. So there are a lot of ideas on ADS, and it may be too early today to say which one will happen first. It will be a matter of having a detailed design that convinces whatever committee will be put together one day to decide which one to make. But the interesting thing is that there are quite a few options, and they will have to be optimized. As for MSR developments, I think there is a need for coordinated effort in order to go from physics to technological solution. The technology for a demonstrator is ready. I think today, if funding was available, I think we could make a system with a 1 megawatt beam and producing 100 megawatt of thermal power. There are issues that remains to be worked out. For instance, the issue of the fuel cycle and so forth. I mean, it is clear that it's a very challenging system, and that not everything, all the details are worked out, but at least there is a clear prospect for a very interesting application of accelerators to the field. There was some discussion of thorium fuel cycle. We just heard about that. I don't want to go to that because I have no more time. But let me conclude on this slide that was shown by Professor Xu Rongjie, which is bringing us down to the reality of our world. Here in Switzerland, people are talking about reducing the energy consumption of Switzerland so that they reach the 2 kilowatt society, which is the dream of some people. And we heard from Professor Xie that in China it's just the opposite. They have to work hard to reach the 2 kilowatt society, and just to achieve that by 2030, they need to almost triple the present electric power installed in China. And this is really a major challenge. Now, I do not know whether that challenge will be met one day by a molten salt reactor or with ADS, but I think we cannot afford not to discuss all possibilities to use thorium to perhaps help with this, because if we continue with the present trend, for instance, the coal consumption has increased 20% between 2010 and 2012. In China, they're commissioning one coal power plant every couple of weeks. It is clear that we will be facing a very dangerous future, and therefore we cannot afford not to do whatever R&D we want to do on thorium. So my conclusion is that there was an impressive amount of work presented on many aspects of thorium technology. There is a lot of efforts worldwide in parallel, and I think international cooperation is a necessity. Energy is a global issue. I believe it should receive a global answer. I think it is possible to converge on concrete projects involving partnerships. We heard Professor Kakotkar saying that if it's too difficult to directly go to an overall project, perhaps we can at least converge on some of the elements that might be easier to get collaboration on fuel, on targets, on recirculation of the molten salt and so forth. So I could imagine that collaboration could materialize around the two main directions that were discussed at the workshop, MSR and ADS, and perhaps there are even some common development. Again, nobody can predict the future, therefore all R&D on thorium is important. On behalf of the organization committee, I would like to thank all the participants to this workshop, especially those who came from far away to participate. This is very much appreciated. I think all contributions have shown a very high level of professionalism. And those of you who did not give talks participated in the discussion, and that was also a nice contribution to the workshop. So let me end everything here by showing you this last photo that actually might be the start of a collaboration, because it started at the banquet, and you can see Professor Rongier and Professor Kakotkar very happily collaborating at the banquet. I do not see why they could not continue this on the development of thorium. So thank you very much, everyone.